Hey guys, welcome back. Today for acids and bases, we are looking at pH. pH is a scale that expresses how strong an acid or a base is. And it ranges anywhere from 0 to 14. 0 to 7 represents acids. 7 right smack in the middle is neutral. And 7 to 14 is basic, which we also call alkaline sometimes. And it is a little counterintuitive because most people think acids are scary, crazy things that can cause lots of damage, so they immediately think that has to be a high pH. And actually, acids are low pH, and the strongest acids are closest to 0 on the pH scale, whereas bases are on the high end of the scale, though bases could also be very dangerous. But today we are looking at calculating the pH and the pOH from the hydrogen ion concentration. So that's like the molarity, moles per liter of hydrogen ions in a solution. And you do this using the negative logarithm of the hydrogen ion concentration. Now, a logarithm is just a mathematical function that you can find on a calculator. And the formula that we're going to use is that pH equals the negative log of the hydrogen ion concentration, which is written as an H plus, that's a hydrogen ion in brackets. The brackets are for concentration. pH equals negative log of the hydrogen ion. Now, to do a logarithm, really all you need is a calculator, and your phone calculator usually has a logarithm if you turn it sideways, but I'm going to be showing you the TI-84 here. The TI-84, sorry, it's got a transparent background, so it's a little bit weird. The TI-84 has a logarithm button on it. The logarithm button is right here where it says log. So you just hit that button, or well, you type your negative first, but then you hit the log button and type in your given hydrogen ion concentration for a question, and it'll pop your pH right out, easy as pie. All right, and we're going to skip over this pre-AP step. Pre-AP people, I will come back to this because you're going to be dealing with it. For regular people, keep watching. We'll get through this. Pre-AP people, I'll circle back around to this in the end. All right, so there's also a thing called a pOH. pH is based on the hydrogen ion concentration. pOH is based on a hydroxide concentration. And the deal is that pH and pOH must add up to 14 total, okay, which is the total width of the scale. So pH, if you wanted to find pH and you had pOH, is 14 minus pOH. Sorry, let me write that in black. pH is 14 minus pOH. And pOH would be 14 minus pH. They add up together to 14 total. pH plus pOH equals 14. So if you can find the pH, you can find the pOH, and vice versa. Now let's do this example down here. It says, oh, my tablet's struggling. It says, calculate the pH and pOH of a solution with a hydrogen ion concentration of 4.90 times 10 to the negative 10th. Is the solution acidic or basic? All right, so what we're going to do is use the formula that pH equals negative log of the hydrogen ion concentration. The hydrogen ion concentration is this number. Let's do the negative log of 4.90 times 10 to the negative 10th. Now you whip out your calculator. I'm going to use my phone because it's what I have right here on me. Turn it sideways to get a logarithm function and type that sucker in. And I get a pH of 9.31. And pH doesn't have a unit, it's just pH. So we leave it as that number. But we also wanted to find the pOH. We're calculating pH and pOH. You know that this number plus your pOH have to add up to 14. So to get pOH, you'll subtract the 9.31 from 14, which would give you 4.69. That is your pOH. Okay, so we've got 9.31 for pH, 4.69 for pOH. Those add up to 14, which is perfect. And then the question asks, is the solution acidic or basic? So let's go up here and look at our scale. If we've got a pH of 9.31, that falls right in here, which is alkaline or basic. So this solution that we've got here is basic. All right, now if you are an on-level student not taking pre-AP, then you can stop this video here and go work on your practice. There is going to be some naming on that practice, so you can refer to your notes from way back when we did naming, or they were on the tail end of the notes from yesterday. You can use those to name the things in the chart. You'll also have to calculate pH and pOH. All right, on to pre-AP. Pre-AP, guys, you have to know how to calculate the pOH from the hydrogen ion, or not the hydrogen, sorry, the hydroxide ion concentration, which works exactly like pH. It's a negative log, but instead of doing the hydrogen ion concentration, you do the hydroxide ion concentration, which is easy peasy. It's still just typing it into a calculator. That is not too bad. The worst step that's a little more difficult is calculating the hydrogen ion concentration or the hydroxide ion concentration from a pH. So let's look at that mathematically. It's going to take a wee bit of algebra skill at first. So let's look at the formulas. We know that pH equals negative log of the hydrogen ion concentration. If you wanted to solve that for the hydrogen ion concentration, you've got to get rid of the log. And to get rid of the log, you have to do an inverse function. And the inverse of log is 10 to the x. And actually, before we do that, we want to get rid of that negative, so we're going to divide this by -1. What you do on one side, you got to do on the other. So you get negative pH, because pH divided by -1 is negative pH, equals log of the hydrogen ion concentration. And then we get rid of that log using 10 to the x. So what you do to one side, you have to do to the other. We'll do 10 to the x, or 10 to the negative pH, which is a given number, equals 10 to the x, not 10 to the x, 10 to the log of H plus concentration. And since 10 to the x and log are inverse functions, those just go away, and you get that hydrogen ion concentration equals 10 to the negative pH. And then if you look at the same thing with the pOH, you get pOH equals negative log of the hydroxide ion concentration. And you could follow a similar process to get that. The hydroxide ion concentration is 10 to the negative pOH. And you could use those to calculate your hydroxide or hydrogen ion concentrations from just pH or pOH. So I want you to go ahead and go back up to the example problem up here and use the pOH that we found, 4.69, to calculate the hydroxide ion concentration for that question. Let's see, let me make that a little bit smaller. All right, so to do that, you have to say hydroxide ion concentration equals 10 to the negative pOH. So you do hydroxide ion concentration equals 10 to the negative 4.69. And you just go type that into a calculator. Simple as that. You do 10 to the negative 4.69, which gets you that the hydroxide ion concentration should be 2.04 times 10 to the negative fifth. Awesome. So what you guys have to do is go fill out your practice chart, which does involve naming as well. But you'll have to calculate the pH, the pOH, the hydrogen ion concentration, or the hydroxide ion concentration. Whatever's not given in the chart, you have to calculate. So it might take you a little bit of time, but hopefully you'll get these formulas down. If you have any questions, please email me or your teacher if I'm not your teacher, and let us know, and we'll help you out.